Welcome back, ladies and gentlemen. We are starting the first session in the post-lunch, operationalizing legacy waste management. This is basically a panel discussion which will happen later on. We have 4 panelists in the beginning, 2 physical and 2 online. So they'll be doing the presentation, and thereafter the other 3 panelists will join in, and the moderator will take us through the session. So first of all, as we are all aware, this approach to Dumpsite Remediation Key Operational Challenges, I would request Shri Shankar Raman, General Manager, Zigma Global Environ Solutions Private Limited, to kindly come over and initiate the first sessions. Yes, ladies and gentlemen, after food, clapping is good. Thank you.
So very good afternoon, ladies and gentlemen. Myself Shankar Raman, working in the capacity of General Manager, Business Development for Zigma. I'll just take you through what is Zigma all about. We are a pioneer in introducing landfill mining services, integrated landfill mining services in India. And how we say that is by virtue of having done about 250 acres of land reclamation and having processed about 74 lakh metric tons of legacy waste. So some of our credentials include, we were the first to be presented as a model biomining project by the Swachh Bharat mission, and it all started in a small pilgrimage site in South India, which is Kumbakonam. And some of our awards and accolades include the Frost & Sullivan Best Practices Award, the most coveted 3R award from the Confederation of Indian Industry with the very senior delegates. And it was awarded by the former Principal Scientific Advisor to the Prime Minister, Professor Vijay Raghavan. And Scott Silver was a recent award, and Vocational Leadership also was a recent award. We do a lot of webinars and workshops hosted by various central and state government bodies, and I happen to personally attend some 3-4 training sessions for SIUD Mysore as well. So unlike others in the industry, we follow something called the zero residue model. And as we speak today, we have employed more than 2,000 people across the country, and we process 10,000 tons of legacy waste every passing day. So these are our credentials. And what it tangibly means to the environment. So having processed 74 lakh metric tons, this is equivalent to about 51 lakhs of carbon emissions saved year on year. And the carbon sequestered as per the EPA standards is about 62 lakh acres of US forest, 1426 wind turbines running for 1 year, and 8.6 crore tree seedlings grown for 10 years. So we have grown, we have reclaimed more than 250 acres of valuable land back and handed over back to the reclaimed and handed over back to the ULBs. So these are some of the pictures of our journey in pursuit of excellence. These are some of the glimpses of the award which we have taken. And this is a very interesting tweet by the Vice President of the country, who has tweeted that if you want to learn about biomining process, take a tour of the Kumbakonam dumping yard. And this was the very first invitation given to Zigma to give the first survection exercise, which happened way back in 2016. We were the first to be invited by the mission director to give a presentation to about 500 municipal commissioners across the country. And these are where we draw this technology from is from a South Korean major called ForceBell. And we draw the technology from them, and we assemble it in India and deploy the machinery in various dump sites. Just to give you a small glimpse of what ForceBell is all about, they have 12 international patents and 24 Korean patents. Some of very noteworthy example to mention is your Seoul Olympic Stadium. Seoul Olympic Stadium is a erstwhile landfill which was converted into an Olympic stadium by the technology player ForceBell. And some of the other complex projects include your clearing of the Fukushima radiation plant, which was devastated by the tsunami, and it was completely reclaimed back to normal order by ForceBell. And this is our national presence. Zigma is a national player. We are present in about 8 states across the country, and more so, in fact, Assam, Guwahati was the recent one which was added to our fold. We are also invested by a venture capitalist, which is a group company, which is Blue Planet Environmental Solutions, based out of Singapore. And as a part of their investment into this company, we are present in about 16 countries across the globe. And they are completely covering the whole spectrum of the entire waste management, starting from organic waste to bioreclamation to C&D waste, and everything in the spectrum of waste management. So Blue Planet was instrumental in bringing the SBI-backed NEW fund, which is the UN Green Climate Fund, into India. And this is monitored by none other than the Honorable Prime Minister of India and Prime Minister of UK. And this is one good initiative which is conceptualized, designed, and implemented in the northern capital region of India, which is a project called Blue Nudge, where we are actually catching the school children and catching them young is the concept, where we are doing a kind of behavioral change exercise in the source segregation. This got implemented in the NCR region, and it was inaugurated by none other than the president designate of the COP26, which got concluded, Mr. Alok Sharma, who also happens to be the UK minister. And some of the awards which by virtue of having Zigma done the biomining, the ULBs who got the awards, Vijayawada Municipal Corporation got the prestigious Scotch Award, Tirupati Smart City got the first award for we having done the bioremediation and biomining in the Smart City category. And just to give you a perspective of what process we follow as a methodology, we follow a four-pronged approach, which is the pre-assessment and analysis of the dump site as a first stage, pre-stabilization of the waste as the second stage, processing and segregation as the third stage, and responsible disposal of the aggregates as the fourth stage. Generally, there is always a misconception that with only trommels the biomining happens. In many parts of the country, this still remains, but we clearly advocate the idea of it is not just trommels, it is a combination of various machineries which form a technology because of which we are able to achieve the complete project execution done. So it is a mixture of, it's a combination of all these machineries apart from the trommels, the air density separators, and some of them are mentioned here, which are all patented. This is an operation flow diagram, as I'm sure most of the experts here do know this. And from a non-sanitary landfill, after pre-stabilization, it is windrowed or coned, and it moves into the weighbridge. It is excavated and moves to the weighbridge for weighment. Then it is stored, and the segregation and the input is given to the segregation area. And the segregation, after the segregation, it is supplied to the recyclables go to the state authorized recyclers. The fine soil goes for reforestation. And the coarse soil and stones go for landfilling. The RDF goes to the cement plants. So this is the most critical success factor of any biomining project, which is the disposal strategy and the environmental compliance adherence. So here, this has been our pan-India experience, gentlemen, where we have completed about 13 projects now, in which what pans out very clearly is about, these are the percentages of our pan-India average, which is 18 to 25% of combustible fraction, which is the refuse-derived fuel. Then the fine soil or bio-earth is to the tune of 4 to 6%. The coarse soil stones form about the major constant, which is about 67 to 77%, and the negligible portion of it is the recyclables, which is 1 to 2% of glass and iron scrap. So these the most essential part of any biomining company has to be the wherewithal to identify and seamlessly dispose the RDF, which easily gets piled up because it is about 25 to 30%. So, and these are some of the last mile reporting of the co-processing certificates which we do from the biomining, from the RDF cement plants. So every fraction which goes out of the dump site is to be tested both through NABL laboratories and from the internal laboratories. And these are the four major T's of our success story, which is technology, adopting to technology right from day one in the dump site, testing practices, the traceability, and the transparency. And I would like to just, this in fact, this is one interesting slide where it gives a very clear demarcation of what, at every minute you can, the ULB is able to monitor what kind of aggregate fractions are being generated and at what percentage. So the ULBs are generally given a link. The entire hierarchy, starting from the commissioner to the lowest down in the value chain, is able to monitor it live, and this gives absolute transparency in the entire operation of the project. So this, I take a lot of privilege and pride in giving you the before and after pictures of various completed projects. There are very few players in the country who have completed biomining projects across the country, and we are one among them. And these are the places. It all started in Kumbakonam. This is a lake reclamation project in the fringe parts of Chennai, and this is Noida, which is this is a very thickly habitated site in Vijayawada, Andhra Pradesh. Again, fringe part of Chennai. Then Gujarat, Atlatara. This is in the external part of Chennai. This is a very interesting project where the dump site was alongside the river Kaveri in South India, which is Erode in Tamil Nadu, where the leachate was flowing into the river, and this was completely remediated. Now it has been converted into a Miyawaki forest now. And some of the other these are some of the ongoing projects. In fact, we are doing the largest marshland recovery in the world in Chennai, which is about 16 lakh metric tons of legacy waste clearance from the marshland. And birds from as far as New Zealand and Australia used to visit this marshland, but it's no longer coming. I hope after the remediation is done, they come back. And Kollam is another interesting site in Kerala where it is a Ramsar site, and it is alongside a lake which we have completely remediated now. And these are some of the buzzword in the waste management industry is about upcycling and resource recovery. So these are some of the upcycled products which is currently still in the R&D stage. And these are some of the other applications of RDF, where we have converted the RDF into furnitures, so which is yet to be productized. So with this, I end my presentation, and thank you very much for the valuable time.
Thank you, Shri Shankar Raman. We now move on to the next presentation by Shri Indrabhushan Gokhale, National Sales Head of PowerScreen. And over to you, Mr. Gokhale.
Good afternoon, everyone. Yeah, just Shankar told it's very difficult to get a post-lunch session. But anyway, I try to make it, it's a very serious topic we are discussing. But I try to make with some stories as I am from the sales background. So it is like that, basically I will give a small introduction to my company. And fortunately, we are very near to you. We are based out of Hosur. So it is just 45 kilometers from Bangalore border. So we can say that we are part of Bangalore. So it's like that. Terex basically market leader in crushing and screening sector. If many of us know about the crushing and screening, so we are in mobile crushers. We have more than 75% market share. Then we are in other type of crushers like stationary crushers and some washing plants. All solutions are there. So in terms of crushing, we have doing from 2000 almost 2000 we are doing from before that is like our dealers are there, but then after we have started our manufacturing here. We have started manufacturing in 2009, and from there means if you for us it's like a very pride that if you know any of the road projects coming there, it is a Bharat Mala project, national highway projects, or any of the road projects in there, we are present, because mobile crushers are very much integral part of any projects. So we are very proud to say that we are associate them. So we have only company which is present in all the segment of crushing, and we are among the fastest growing company of the CE. But the things will be not end here. Is like when do the crushing? If many of you knows that when we do the crushing, it is like that we have to crush the stones, and the stone used to carry the rust. So I am there in crushing industry for last more than 16 years. So most of time, unfortunately, I work for the NGOs where they have a tree plantation, everything. So most of time I have a very much not a question in my mind, what are we doing? We are creating a lot of pollution, lot of of course it's until unless we crush the material, how we can build the road. So it is like that, this journey has started, and then after this solution has come, and then I'm the one of the key member in my company to push this product, because this is a crushing product. What we'll see, it is a crushing product we push in the and I will take one line from Mr. Sridhar that only Trommel can't do that, we have to add the technology. So we are basically adding a technology for this. So these are the some more figures, very means you people are more expert than that, but it is some of the survey. It's like that in India around 150 tons of solid waste. It is almost around 62 million tons every year. So this is basically data. So this will derive us. There's a lot of demand for this product. It is like presently it is 62 tons in 2016, 2013 it will be around 165 tons, and 2015 it will be 436. So it is basically, it is like that. It is like the material which is available for us. For in crushing, we always have a question from where the material will come. But in this case, material is ready for us. So we have started our when in 2016 or something, we started our research work. So in that we come to that the MSW municipal solid waste, what are the major contents. Everybody knows about this, and legacy waste that can be collected and kept for 30-40 years. So that basically it's a main. So we see that when our team has visited, so they see that a lot of legacy waste dump yards are there. So around 2,000 legacy waste dump yard, and it is very, very high. It is around 213 feet, 20-story building. This is one of the picture of Delhi Delhi landfill. So our team has started there, and then after they have started researching on what kind of legacy waste is available. We have done research from being a crushing manufacturer. It's a very easy job for us to take the data from us, because most of our service engineer are placed. So we see that the dump yard in Jammu and Kashmir contain riverbed material. That is it will be flooded many times. When we come down to the Latu is a place where I belongs to Maharashtra. So the experiments start from there itself. So it's contain organic waste, plastic insert, dump yard. So these are the various types of waste, and most of us know about this. So before going to this, I will tell our journey. It's on 2016. So there is also a very interesting story. Maybe in some I stayed in Hiranandani, Mumbai in 2016. 16 when this product we announced. So yeah. So what happened? So what happened is that. So I was sitting on a Sunday morning with my wife. So she said that I told today Met will come late. Means I told why she will be late. So she said she is gone for training. I also see that why she has gone for training. Means its training is required, I thought, but she has gone for training to how to collect the waste. There is here also now it is implemented that should be there in India means in our Mumbai language, Ola Kachra, Sukha Kachra. It's like that. So it is very compulsory from 2016-17. Brahan Mumbai Mahanagar Corporation, Thane Management. So this is like that. So there also I come to know that this is a problem. Is we can get some solution. In 2016 we have we done research in Latur. Then we have one of our demo machines available. So our dealer is Voltas, very well known company. So they said that why can't you give the machine? So we said that why is it going to work? Means if it is not going to work, it will come back, because customer told that I will use it. One of the premium player in this, Mr. Kore is from Sagar Motor. He said that just utilize that, we will help out, because this machine I feel that it will produce. Then we'll contact our UK team and everything. So they said that let's go ahead. So we have a demo machine. So demo has run in 2017, and finally it is being tested that this machine can be utilized in place of trommel. Of course, we don't want to get into trommel. Is a big market and there are a lot of players. But it is like it can be part of your solution system. We have seen sir told that. So it is one of the part of the solution. It is like that whatever the trommel is used doing, because one of the case study that has came, and we are very much surprised that the first machine which has gone, it has producing 10 times more than the traditional trommel, and the cost wise, operating cost wise. So we had let's go ahead, and then after but problem is that once we get into that, we have this is the separation in the barrier. This is compose, insert and RDF. So the same thing what trommel is to do, it will do more than means if it is 150 200 tons in a day, it can give up to 1000 tons. So we have but once we started, we have facing a lot of challenge. I think during the seminar also we come to know that there is some ignition issue, so our machine has also catch fire, means like that it is. So we have done all the provisions, as we are the here only, so our team was there, so we have done the provision for that. You can see there the exhaust pipe, we have make the changes. These are few of the changes. Then whenever there is a bottom deck, there is a wire mesh clogging, so there we have changed the decks, where we have moved to very smaller wire mesh. Then after we change we have made the changes in the engine manpower, engine power. And then if you see the result, today we almost having the more than 53 machines located across India. It's of course none of them is a reference in Karnataka. Will definitely maybe in 1 or 2 months we will definitely get our machine, but everywhere it is present, if you see. And there are a lot of orders are coming in a pipeline. So we have so again means we have done the machine. Then after we come to know from the Delhi Municipal Corporation is sometimes generally this machine has hardly fuel consumption 4 to 5 liters, but generally there it can work on if your machine can work on electricity, then it will be better. So we have now we are launching with the hybrid version which can work on electricity as well. So these are some of the that just recently sir told that these are the some of the where our machines has work. And these are some of the media coverage we got it, and we are very, very proud of that. Even the Swachh Bharat mission, Urban given as a front page story. I mean, it's not story, it is just printed on their line. So better than I am telling you that what about just I will sum up my presentation with one of the videos from my client.
Is a good alternative to drone. हम लोग वेस्ट मैनेजमेंट बिजनेस में पिछले 12 साल से हैं. रिसेंटली हमने सॉलिड वेस्ट मैनेजमेंट का काम शुरू किया है ईस्टर्न इंडिया में, इंक्लूडिंग वेस्ट बंगाल और दिल्ली. वेस्ट बंगाल एक ट्रॉपिकल वेदर का एरिया है. जहाँ पे ट्रॉपिकल वेदर होता है वहाँ पे बरसात बहुत ज़्यादा होती है. तो बंगाल एक ऐसी जगह है जहाँ पे 6 महीने पानी पड़ता है. ऐसे परिस्थिति में जो लेगेसी वेस्ट है उसमें मॉइस्चर बहुत ज़्यादा होता है. जहाँ पर वेस्ट में मॉइस्चर होता है, ऐसी परिस्थिति में ट्रॉमल जिसके सीम्स बहुत छोटे हो वो जैम हो जाते हैं, और जैम होने के कारण प्रोडक्टिविटी बहुत कम हो जाती है. तो ऐसी परिस्थिति में एक विकल्प के रूप में हमने PowerScreen वॉरियर 1200 को लॉन्च किया. उस प्रोडक्ट के माध्यम से हमने बहुत अच्छा आउटपुट पाया. यह मशीन इसका मेंटेनेंस कॉस्ट बहुत कम है, फ्यूल कंजम्पशन इसका बहुत कम है, और बहुत ही अच्छे से रिलेटेड फ्रैक्शंस भी.
कोलकाता मेट्रोपॉलिटन डेवलपमेंट अथॉरिटी के साथ में, जम्मू म्युनिसिपल कॉर्पोरेशन के साथ और कंटोनमेंट बोर्ड में हम लोग काम कर रहे हैं. टोटल कैपेसिटी की अगर बात की जाए तो करीब 18 लाख टन हम लोग इसमें प्रोसेस कर रहे हैं. और लेगेसी वेस्ट के ट्रीटमेंट में बेसिकली सबसे बड़ी जो बात होती है वो होती है इक्विपमेंट का सिलेक्शन. उसके लिए हम लोगों ने जो है कई जगह बातचीत की, पूरे वर्ल्ड वाइड जो है हमने सर्च किया, और लास्ट में हमें ऐसा मिला वो है बेसिकली वॉरियर 1200 PowerScreen. ये मशीन ट्रैक माउंटेड मशीन है. साइड के अंदर जाकर के जहाँ पे आपका कचरा है वहाँ जाकर के काम करती है. कचरे को आपको ठो करके नहीं लाना है मशीन के पास, तो आपका जो लीड कॉस्ट है वो उसमें सेव होता है. दूसरा चीज़, इस मशीन की जो पर आवर डीजल की अगर हम बात करें तो वो बाकी टेक्नोलॉजीज के कंपेरिजन में बहुत ही कम आती है. मतलब ये हमारे प्रोजेक्ट को एक वायबिलिटी की तरफ ले जाती है. चूँकि मशीन जो है इस तरीके से डिज़ाइन की गई है, इस तरीके से इसकी इफिशियंसी और क्वालिटी एश्योरेंस किया गया है कि इसका मेंटेनेंस बहुत कम है. दूसरी चीज़ इस मशीन की है कि जो सर्विस सपोर्ट जिसकी हम बात कर रहे हैं वो बहुत ही कॉस्ट इफेक्टिव है. हम लोग इस मशीन के साथ बहुत ही सेटिस्फैक्शन से काम कर रहे हैं.
So these are some of the, we got I think 4 or 5 awards. These are some of the awards we got in recently on XCon. So thank you so much. Thank you organization, and thank you all the audience for listening us. And anyone wants more information or any type of solution, so just let us know. Myself and Ramdas, he's a regional manager here. You just tell us if any of your customer or any of your consultant want to get more information. We are ready to provide us for the equipment. Thank you so much.
Well, the first 2 presentations in the post-lunch were on time, so we are heading in the right direction. We now have 2 back-to-back presentations on the virtual mode. First of all, I would request Shri Masood Mallick, Joint Managing Director, Re-Sustainability.
Have worked on are in the category of inerts. I'll talk a little more about this. There are some complex technical, economic, as well as environmental considerations that, in our experience, must be kept in mind as we are approaching not just the existing dump sites, but some of the biggest, more complex dump sites that are still ahead of us. I think a lot of good work has been done on small dumps, 50 acres, 100-acre dumps. But there are dumps which are 200, 300 acres. There are dumps which are millions and millions of tons. And they are right in the middle of big cities, mega cities, high population density areas. And therefore, the whole concept of biomining leading to real estate redevelopment, I think, needs careful evaluation. The reason why I say so is because, this is the typical approach. In this slide, you will see the typical approach to biomining, where there is X tons of biomining is happening every day, processing of waste. There is a lot of processing, recycling, upcycling of materials, etc. Some of the materials, in some cases, gets capped on site. In some cases, it is sent off site. In most cases, it is going off site. Typically, the fractions that get talked about are these. There is the RDF, there is the compost and the biosoils, and there is the aggregates, which are typically used as aggregates, really. The question that I have, and that we have been struggling in all the projects that we have been working with, is the quality of these products. We all know that there was never any segregation of waste that reaches our dump sites in India. It is a commingled waste, municipal waste, together with a lot of potentially hazardous substances, domestic hazardous waste, batteries, lamps, etc., that goes there. What happens over time is, we talk about RDF, or refuse derived fuel. We operate the largest portfolio of waste energy plants. We are the largest producers of RDF in India. We understand RDF. The RDF that comes out of legacy dump sites hardly has any calorific value because the volatile is already gone, long gone. The fact is that the calorific value in RDF is mostly associated with plastics. And as plastics degrade over 5 years, 10 years, 15 years, 20 years, they lose that calorific value. The compost and the biosoils, there is hardly any bio left after 15, 20 years of dumping. So it's essentially the soil that is left. Unfortunately, it is the same soil that tends to concentrate heavy metals, because while volatiles go away, heavy metals often concentrate and stay behind. They don't evaporate. They don't volatilize. And the same for the so-called inerts. And therefore, when we look at dump site rehabilitation, any dump site rehabilitation, I think the most important consideration, and probably something that often gets ignored in many projects, is the characterization and very detailed site-specific characterization. Another area that gets ignored is leachate. What you see above ground, that mountain that you see, is actually the tip of the iceberg. Below that, often many times bigger than that mountain, is an inverse pool of leachate that is below ground. That's the real iceberg. And that is what represents the biggest environmental as well as human health risk. How many projects are we really factoring in leachate treatment the way it should be factored? How many projects we are characterizing that leachate, treating it? It's millions of kiloliters of very complex leachate that needs to be treated. And the associated groundwater contamination, landfill gas management, slope stability issues, health and safety issues. Where is this site located? What is the likely future land use? What receptors? Obviously, there was a learned colleague from an equipment manufacturer. He's talked about choosing the right equipment. I completely agree. And depending on whether this is a small dump site or a large dump site, the equipment complexity also changes, the scale changes. The economics is, as I'm sure the experts in this field will agree, is primarily determined by how much far you need to transport the RDF. What is the distance required for either dumping the so-called inerts in a low-lying area, or using it for some road filling project, or transporting the RDF to a cement kiln or to a waste energy plant. If it's really inert, what is the environmental cost of transporting it? What is the carbon footprint of transporting it? Is it really inert? And if it is not inert, is it being treated like a hazardous substance? These are some very complex issues. And therefore, when you're looking at analysis of alternatives, do I take it or do I find an alternate management direction for it? Are we really looking at both the environmental cost, the carbon footprint, and the economic cost of that treatment option? And the whole uncomfortable issue of mass balance. Everyone talks about the fact that there was a mountain there, the mountain is gone. So that's great. But again, what about the contaminants that were there in the mountain? Where have they gone? And what is the traceability of the contaminants today? Or have we essentially, like I said initially, is it a dump site rehabilitation is equal to dump site relocation? And while we are doing that job, obviously impact on the residents and number of issues associated with long-term O&M. Today, I mean, all over the world, and I have worked on international dump site rehabilitations. I worked in rehabilitation of the dump site where the Sydney Olympics was held. I worked on the dump site where the Seoul example that was given. The O&M of those projects still going on. The long-term monitoring of groundwater, the remediation of leachate in many of these dump sites goes on for decades. How many of our dump sites are true remediation projects? Or have we just removed what is visible and what is easy and cost-effective to remove? So the not so typical approach. How many dump site projects have leachate treatment plants? There is a 2 MLD leachate treatment plant in one of the projects that we are working on right now. It's extremely expensive. It's 200 odd crores of capital cost on the leachate treatment alone. How many dump site rehabilitations really take into account that kind of leachate treatment and recycling infrastructure? How many places is really an odor management system or a landfill gas management system incorporated into the design of a rehabilitation? To what extent groundwater monitoring and long-term remediation is part of a biomining or a rehabilitation project? These are some considerations that I would request and encourage become a part of the standard approach, not the not so typical approach. And there are many great examples in India of complex, large, this is a 325 acres dump site that has been, out of which 200 acres was biomined. Single location, 14 million tons using high rate biomining equipment. This is a former dump site where from the former dump now auto fuel is being made. From landfill gas is being converted to CBG. And this is probably one of the first such projects. Many, many great examples in India of solutions as well, not just challenges. My only request is that when we look at any dump site rehabilitation, we have to look at it holistically and look at both the economic cost and the environmental cost, not just with the visible component of the dump, but of the real environmental risk associated with that dump, which includes the contaminants within the dump site and the leachate underlying the dump site. Thank you very much.
Thank you, Mr. Mallick. And now we have the final presentation on the virtual mode. I would request Srimati Swati Singh Sambyal, Waste Management Specialist, UN Habitat. Srimati Swati online. Can you hear us, ma'am?
Yeah, I can perfectly hear you. Am I audible?
Yeah, audible.
Okay. So thank you so much for this very relevant discussion and conference. And apologies for not being able to make it to Bangalore in person, but not taking much time and starting straight with the presentation. So this is Swati Singh Sambyal, and I'm a Senior Waste Management Specialist with UN Habitat India country office. Also, thanks to Masood ji for addressing the elephant in the room and also sort of highlighting some of the issues that we don't often talk about, Dumpsite remediation projects. While I'll be sharing more about Fukuoka method, which is a low-cost remediation methodology, which UN Habitat has been implementing in a few countries across Global South. But before I do that, a brief overview of our office's work in the state of Karnataka. UN Habitat as an agency is working on sustainable urbanization, primarily towards fulfilling the SDG goal 11. We are very closely working with Ministry of Housing and Urban Affairs and other state urban departments across the country. Specifically to Karnataka, there have been two very relevant projects that we've just finished. One, of course, is the Sustainable Cities Integrated Approach pilot that looks into integrating sustainable strategies into urban planning and basically creating green and circular investments and infrastructure with an aim to reduce greenhouse gas emissions. In Karnataka specifically, of the 5 pilot cities, we worked in Mysuru with the Mysuru Municipal Corporation. And some of the approaches that the project entailed was defining spatial strategies, looking into solutions and direction, preparing city profiles and diagnostics based on the spatial and data analysis, and then preparing urban sustainability indicators report. So for Mysuru city, you can see that this report is readily available, basically a planning and management tool that could support 12 sectoral interventions, right from waste management to sanitation to climate change to urban transport to mobility. So if anyone in the group is interested, I'd be happy to share the details. As a city overall, Mysuru sort of topped in solid waste management, water, sanitation, finance, but we also sort of identified of the 12 sectors that we analyzed some areas where work was required, based on which key intervention projects were devised for Mysuru. One, of course, on mixed use infill development in new neighborhood centers. Secondly, on cycling network and pedestrian infrastructure. Third, on increase and protection of green and public spaces. And lastly, on the need of digital governance initiatives. So we are very closely working with the city corporation and other stakeholders. Other area where the organization widely works is, of course, we have a global program, which is called the Waste by Cities program. Presently, we work with over 200 cities worldwide, about 40 cities in India in fostering cross learnings across resource efficiency, circular economy, also looking into advocacy and education, and also fostering circular financing to ensure that when such projects come in cities, there is good bankability and support. Some of the key intervention areas in India around waste management for us, of course, are evidence-based planning. We feel data is very integral to any kind of planning activity around waste management. Then around technological solutions, more looking towards frontier technologies, but also looking into social entrepreneurship, policy integration with circular economy, and capacity building of stakeholders. A very recent intervention which we just finished, and I saw that Mangaluru also presented, was a very significant project called Tackling Plastic Waste in the Environment, wherein we worked in 2 pilot cities in India, but about 6 pilot cities worldwide, including Ethiopia and Kenya, And in Mangaluru specifically, we sort of worked with local groups and NGOs as well as with the Mangaluru City Corporation on conducting a comprehensive diagnostic municipal solid waste assessment. And based on that, an action plan was developed and a circular investment proposal was developed, which is currently underway. I mean, of course, the project has been approved, but we are also looking into bringing it onto the ground within the city. So really thankful for the support that we got from the city administration for conducting this work. And some of the results that came out, typically when you look at data in cities, it's not available, but this exercise wherein we utilize the Waste by Cities tool that is developed by UN Habitat, we were able to look into the waste flow chart of the city, what are the leakages that are there in the city, where those leakages are going, and also based on that, looking into the formal and informal recovery chain and devising an action plan over a period of 1 year, and based on that, defining priority intervention areas. So that in a nutshell has been our work in the state. Coming back to the topic, which is landfill remediation, I'll be majorly focusing on this technology, which is called as Fukuoka method, and UN Habitat has been instrumental in applying it in 17 nations. We very much hope to look into implementing this affordable low-cost technology, which Mr. Mallick also addressed. I mean, we have to look at holistic solutions, not just securing the top layer, but also addressing the problem which is often not visible, which is the leachate. So of course, it's a holistic, low-cost, sustainable landfill remediation methodology. If you look into what is it, it's a semi-aerobic remediation method, which was put into practical application in 1975. And in around 1975, this was adopted as a standard design for Japan's final landfill site guidelines. Now, what is the difference? Basically, compared to conventional anaerobic disposal methods, majorly open dumping, this technique sort of looks into improving the water quality of leachate, reducing the amount of hydrogen sulfides and other volatile organic compounds that are generated, looking into early stabilization of landfill and dump sites, and suppressing GNGs. As the previous speaker sort of widely mentioned, I agree the same, that most biomining and biocapping interventions do not focus on holistic aspects, but are majorly focused on the top layer. But it's important to look, at have an overall approach when you're looking into something as complex as landfill remediation. So basically, if we sort of compare a normal site and a Fukuoka remediation method, basically in an aerobic landfill method, which is widely used in developing countries, the landfill layer has an aerobic atmosphere. There are not only problems in terms of sanitation, such as deterioration of leachate water quality, odors caused by generation of hydrogen sulfide, but there's also the risk that generation of methane gas will trigger fires. We've seen this past few months at many sites, especially at Delhi. With the Fukuoka method, air naturally flows into the landfill layer through the leachate collection or discharge pipes, so that an aerobic atmosphere is maintained and generation of methane gas and hydrogen sulfide is suppressed by vigorous microbial activity. And as a result of this, an odor improving effect can be expected and the landfill can be stabilized at an earlier stage. In addition, since the design prevents leachate accumulating inside the landfill layer, this method can be expected to improve the water environment, both inside and outside the disposal site, compared to other interventions. Furthermore, by undertaking appropriate maintenance management, the final waste disposal site can be stabilized at an earlier stage, and the costs can be significantly reduced. So also with this technology, we're looking into the affordability of a landfill remediation project that is generally not looked into. So these are some of the pictures of open dumping in Fukuoka, how the site was, and how this work was in the initial years carried in Fukuoka University. And as you can see, there's a field survey going on. Some of the steps that are entailed while conducting this study, of course, is the rapid assessment, wherein an entire baseline assessment of the site is done, which is again very, very important. Then, of course, you look into the leachate, and then followed by capacity building, and then finally the implementation phase, followed by a pre and post monitoring phase. Now, if you look at these graphs, they show the periodic change of leachate quality generated from waste lysimeters, and the indicator of pollution, which is BOD and total nitrogen conservation rate. It is seen that it was largely reduced by blowing air into the landfill model tank. These are again some of the pictures from the site, and as you can see that the test tanks were dismantled after 3 years of experiment. And if you look at the 2 photos of the right side, they show the waste conditions after 3 years since it was landfilled. And top photo shows the waste degradation without direct air blowing into the wasteless. Bottom photo shows the waste degradation with air blowing. And of course, it results from the difference with or without air, the anaerobic and aerobic conditions that are created. And as you can see clearly, when you look at the leachate over a period of time, there's a drastic improvement. So these are some of the on-site pictures that were the first project site from 1973. If you look at the top drawing here again, it's a traditional landfill model. The bottom drawing is the model using Fukuoka method. And of course, I explained its details that, through the leachate collection pipes, leachate in landfill is swiftly removed to outside of the landfill. Simultaneously, fresh air naturally blows into the waste layers from the bottom of the landfill, which is due to the fermented heat convection effect generated by microorganisms activity in waste layers. Also, again, it's a natural technique, and by applying this mechanism, even without electricity, a landfill is naturally able to improve itself to aerobic conditions by installing the leachate collection pipes at the bottom of the landfill. Again, these are some of the site pictures. And if you look into the fact that you don't sort of remediate sites to sort of reuse them as landfills again. So you can clearly see this is a park. It's a tennis court, which was after the landfill remediation. It was remediated, rehabilitated to a court. This is a school. This is again a park. This is again a public garden put in use after remediation. Some of the other sites where we have worked include Malaysia, again, where a lot of work happened at its oldest dump site. As you can see from some of the pictures, the status from what the site was to what the site became after remediation and applying for Fukuoka method. We have been extending technical cooperation and technology transfer in many countries worldwide and not adopting Fukuoka method. And presently, we have completed projects in over 17 countries, of course, in cooperation with various governments, municipal departments, as well as other institutions and companies. This is, these are some of the pictures of a project in Iran where Fukuoka method was applied. These are some of the pictures from Samoa where a similar intervention was used for landfill remediation. Again, in China, where there was a bilateral agreement to work and remediate a site. This is a project in Pakistan, which was undertaken to remediate a landfill dump site with Fukuoka method. This is in Vietnam, where it was undertaken. This was in Kenya, and the most recent one, wherein in Gokhale landfill in Addis Ababa, as well as in Bahir Dar, we have applied Fukuoka method. And as you can see, Gokhale landfill, of course, has been in use for obvious reasons. It has been a dump site that has been used forever for the city of Addis Ababa, as well as outskirts. And it was a 10-month implementation project that is now under completion. And presently the work is going on in the city of Bahir Dar in Ethiopia. So these are some of the initial pictures of the site. If you look at it, the before and after implementation interventions, these are some of the drawings of how the slope would be stabilized, and then sort of the site could be reused for vegetation and rehabilitation. These are the pictures 4 months after project completion. This is after 6 months, where vegetation and sprouting was sort of tried after applying the Fukuoka method. And this was the intervention, very recent pictures taken from Bahirdar city in Ethiopia. Also, currently a project is going on in Myanmar, where we are remediating a site, and it's an ongoing project utilizing Fukuoka landfill remediation method. Some of the strengths and benefits and why we feel it's an appropriate technology. Of course, it's low cost compared to other conventional technologies. It's simple technology to reduce methane emissions and pollutants, including leachate. This has been approved by UNFCCC in 2011. Of course, we look into complete reuse of land after completion and do ensure that the land is not again utilized for dumping. But these sites are either developed as integrated processing facilities or they are rehabilitated to other uses. One benefit, of course, is that we entail and localize the technology based on availability of local materials. What's available at the site, what's available with the city administration, to sort of significantly reduce costs, and also look into training labor, local resources, waste picker organizations, as well as municipal staff to undertake such a project. And of course, it's job creating. It's not just a project that you finish and leave, but it also creates the strength within the city to deal with, incidents like landfill fires or whatever menace that happens due to such sites. In India, of course, we did an initial Kickstart meeting in late 2020, wherein we had a meeting with CPCB, an initial dialogue with over 110 municipal corporations on Fukuoka method. It was a Kickstart meeting. After that, we've had a few consultations with Mahua. Also have been in close talks with a few cities in the country where we're looking into collaborating and working and applying this pilot low-cost affordable technology. At least it'll be the first one in India wherever we start. In terms of way ahead, of course, we all as solution providers and experts have to look into opportunities to work together and offer hybrid solutions to foster cross learnings. No technology is complete in its whole, so it's definitely important to sort of, take the best from every technology and look into hybrid solutions. Of course, as we're talking about circular economy, there's a need to reduce, minimize our dependence on landfills, adopt both bottom-up and top-down approaches. Learning and replicating best practices is equally important. And also not close our eyes to more holistic interventions. And as the last speaker also said, I truly believe that composition decides technology. So evidence-based analysis is the first step towards deciding technology for remediation, and focus on G&G emission reduction, because clearly landfills are not the answer. We cannot remediate with an intention to use these sites as dump sites or landfills again, or and then seek for another site in someone else's backyard. So about time we move to circular and more holistic solutions. I think I'll close here. Thank you. Yeah.
Thank you very much. Stay tuned as we are going to have the panel discussion right away. Without much ado, I would request the moderator, Shri Manas Rath, Senior Advisor, BORDA Asia, to kindly come over. And also the esteemed presenters, Mr. Shankar Raman, General Manager, Zigma Global Environ Solutions, kindly come back. We also have Mr. Indrabhushan Gokhale, National Sales Head of PowerScreen. Mr. Masood Mallick will rejoin us. He's already there online. Joint Managing Director of Sustainability. And we also already have Srimati Swati Singh, Sambyal, Waste Management Specialist, UN Habitat. I would also now request Mr. Sampath Kumar, Founder and CEO of Tide Technocrats, to kindly come over. Mr. PH Jadhav, Solid Waste Management Group, Pune. And we have one more gentleman joining us on the virtual mode, Shri JB Ravinder, Joint Advisor of CPHEEO.
So I had a question starting a quick question for Dr. Ravinder. When you saw the presentations today, and given what's happening with all the various legacy waste site, landfill projects going on in India, what are some of your, where do you think they are meeting the goals and the objectives that CPHEEO would lay out? And where do you think we are falling short, or what do you think we are not yet focusing on in the landfill remediation projects underway across India? So could you, Mr. Ravinder, could you hear me? We can't hear you. He's muted? Okay, I think you'll have to unmute yourself. But is the Zoom audio connected to the main system? Okay, maybe let's start with the question with the folks on stage till we figure out our online sound. I think one of the questions I'd like to ask, and maybe Shankar, you can start with that, is what are some of the, we saw a few successful case studies before lunch, right? And a lot of projects are going on. What are some of the obstacles or roadblocks you're seeing in some of these projects, and what can be done to make the process smoother so that we have quicker completion of projects, hopefully lower cost and better outcomes in these landfill remediation projects that you're seeing?
The very first one, which I would like to mention, is about the quantification. I think the ULBs need to quantify it better. Yes, of course, the contractor has the responsibility of doing a quantification once the project is awarded, but prior to the project getting awarded, the quantification below the ground level is not quantified at all. So that is one critical point which needs to be addressed. And number two, leaving Karnataka, one state, one price across the country, this has been our experience. One state, one price is being followed in maybe states like Maharashtra, where this is not a rate contract of a product. This is a services being offered. So there are many factors which need to be factored in before arriving at a kind of price per metric ton on the tipping fee. So that is something where there are a lot of projects which has gone haywire because of this, the pricing not being budgeted properly. And thereafter what happens is, post that, there are to our surprise, we are even seeing tenders coming out for disposal of the RDF, which is after the biomining. After the biomining project got awarded, after the project period got over, now the same ULB is coming out with a tender for disposal of the RDF. So which is very strange. So I think these two are very key success factors. Yeah.
And would you say that disposal should be part of the biomining?
100%. It has to be an integrated part of it. It is an integrated approach which the ULB has to adopt. Yes.
Right. Okay. And Mr. Jadhav, same question to you. What are the kind of, in your experience, could you just, in half a minute tell us what size of projects you have worked on, and what are some of the obstacles and problems you have faced?
I had worked size of the project ranging from 50,000 cubic meter to almost 4 lakh metric ton. So I have a little bit much more experience in small and bigger sites.
Yes.
So I will elaborate more Mr. Shankar's point that cost will be also on that size of them, because capital cost varies. Otherwise, what will happen? For small, there will be no good players for this. And also, For small project, there should be infra cost should be beared by ULBs, like electricity setup, then water and shade if possible, and also weighbridge, such a facility, because cost of project is 1 crore and that setup cost is almost 30 to 40 lakhs. So this should be addressed.
Right.
Almost all points are covered. I
Okay.
think.
So make sure that all the proper setup and infrastructure required that is provided properly, and then the pricing should take into account proper local variances, including the capex requirement, integrated projects, integrated contracts, and I guess I would say better as part of the quantification. I would say really there need to be better. The process of designing the contract has to be done much more robustly with better technical expertise, better economic, so estimates, etc. So maybe more effort into the consulting side or into the DPR side of things, right? Perfect. Okay. Is online working now? Yeah, perfect. In which case we can have the question to Dr. Ravinder. I don't know if you heard me earlier, but I would be curious to learn from the presentations you have seen and also the projects that you're seeing actually happening, the contracts and the projects that are underway and getting completed. From CPHEEO's technical perspective, what goals are we achieving with these projects and what goals are we not achieving, so that when the DMA is thinking about how to do these tenders and projects, what else should they be keeping in mind from a long-term perspective from the concept of livable cities, sustainability, and making sure that the health of both environment and people is properly protected? One second, we can't hear you. Are you on mute? No, okay.
Great.
Okay, we can hear you now.
Yeah, thank you. And when we are looking at these remediation projects, we want to clear off these, what you call, in a reverse way, icons of mismanagement over the years. And we would like to convert them into rather green zones. What is visible only we are attempting to clear off, and what is not visible, as some of the presenters have said, what is the groundwater contamination and the consequences of it. It is a very long-term thing and we are not looking at it unless that area has been declared as a hazardous as far as the groundwater is concerned. Then it comes into another project under the Ministry of Environment and Forests. Sorry about that. So we are basically looking at clearing of these sites so that these mountains and mounds of dirt, accumulated dirt, having lot of socio-economic degradation of the community around there is eliminated. Those areas nowadays happen to be almost in the heart of the city. Maybe 20-30 years back they were on the outskirts. So we are basically looking at these things, that the visible ill effects of these dump sites are removed through remediation.
Yeah.
We would also like to actually do any leachate management that incidentally occurs there in a visible fashion. And once again, I reiterate that what is invisible about the groundwater contamination, etc., we are not looking at this stage. Thank you.
Okay, thank you very much. Mr. Masood, coming back to you, the elephant in the room that you raised. I have a couple of questions to follow up on that. And actually, let me just how much more time do we have on this session? I know we're running a bit late. 15 minutes? Okay, fine, great. Okay. Now, should there's obviously always, we looked at some of the big numbers this morning, how much is it going to cost to clean up the landfill, 1 lakh crore and, whatnot, right? Now, there'll obviously be a drive as this becomes a more mainstream activity and service there'll be a drive to try and reduce the cost. And typically what we are seeing today is 450 rupees to 800 rupees per ton seems to be what it, what it costs. And then that benchmark number kind of gets set, right? And once a benchmark number gets set in the minds of people, if there is a project which is much higher cost or much lower, it raises eyebrows. Why should we spend so much? We don't need to spend so much. You pointed out to some of the gaps, and it looks like, what we are doing is sort of jugaad the Indian way, right? Do it quick, do it cheap, do what's needed, and, sort of avoid too many questions. In your mind, good quality landfill remediation, and I know there'll be a variety based on how big it is and what the, what climatic condition it's in, but in your mind, do you have a sense of what should it be costing us if we really want to do the landfill remediation in the most responsible and proper way possible?
That's a great question, but I must state that there is no two landfills are the same, because risk is not driven by the source. Risk is driven by the receptor. A landfill in the middle of nowhere without any sensitive ecological or human health receptor right next to it has very low risk. And the environmental controls and the remediation strategy will be different. But a Balaswa or a Ghazipur or a Deonar, these are very different landfills. We're right next to high density human settlements, where incidentally there is a high degree of contact with groundwater. People are actually abstracting groundwater, using groundwater in these regions. So risk is driven by the receptor, not by the source. The mountain does not drive the risk. The people around the mountain drive the risk. So so there is no one size fits all. Let me just share some. There was an interesting question. Similar question was asked by the office of the PSA. The PSA himself, the earlier principal scientific advisor to the government of India, asked us this question: that what should it cost to even just study a dump site like Ghazipur, which is a large dump site? On a pro bono basis, as part of CII, investigated and prepared a detailed design of a rehabilitation for Ghazipur landfill. The cost of just the investigation was 6 crores, because drilling and profiling and coring an old dump site, especially which is 70 meters tall, is not easy. The kind of studies that are required, the kind of sampling that is required, the kind of analysis that is required, the kind of modeling that is required is not easy. Right. And that effort, the cost of that, the bare bones cost of the investigation alone was 6 crores. The cost of treatment of 1 kiloliter of leachate, 1 kl of leachate, is anything from 450 rupees to 1200, 1300 rupees, depending on the concentration. 1 kiloliter, right, which is essentially 1000 liters. So I cannot give you a uniform number. I think there are multiple approaches to landfill rehabilitation. Right now, we have identified sort of one size fits all. And I think a very good point was made by one of the previous speakers, who said that there is uniformity now that is being said. One country, one rate kind of thing. Unfortunately, it's a diverse country with diverse socio-economic environmental setting, and that setting informs what should be done, as opposed to just going by 500 rupees. Everyone is doing it, I'll do it at 500 rupees. Then what will happen? It will be a relocation of that dump site at the lowest possible cost to some place where tomorrow our children will be paying to rehabilitate that.
Absolutely. So I guess that goes back to the point that Shankar also made, that we need to do the study properly, and case by case basis, depending on the location, depending on the risk factors that are present. And I guess the larger landfills that are closer to the cities are going to cost dramatically more to rehabilitate properly. And maybe for small towns, maybe the approach that we're using is, and I won't say okay, but maybe little more okay, where one may not need to go as deep because the quantum of waste, etc., is lower, but still that characterization is necessary.
May I just make one last point on the cost issue?
Yes.
If we go into a very site-specific design and remediation strategy, it is possible that partial redevelopment of land can be used to pay back and to recover cost. Partial controlled redevelopment with zoning controls, with exposure controls, knowing what can be developed here and what cannot be developed here. And this is how it is done in other parts of the world, where actually a consortium of real estate developers actually fronts the money. And they know that they only be allowed certain land use for a particular duration, and that is how the cost of the rehabilitation is recovered. The submission here is typically removal of a dump site from a location results in 6 to 7 times appreciation in land value instantly.
Right.
Sometimes it is many times more.
Yeah.
For the neighboring landowners.
That's right.
Not just for that land. It's not that, if you clear a 50-acre land, it is that land whose value got appreciated. In a 2-kilometer radius of that dump site, land value appreciates. Economic value is being created by this whole process. We should look at it holistically and allow for a proper rehabilitation so that tomorrow it is seen as something which is truly sustainable.
Right, and so therefore that opens the avenues for different kinds of public-private partnerships, potentially for outcome-based financing or outcome-based projects. Of course, given the general reputation of the real estate sector in India, one needs to be careful about what is actually monitored, what is reported, and what is achieved. But your point is basically that we need to, if we think more holistically, then the higher cost of doing things the proper way might become viable, at least in certain locations. I mean, it does trouble me that very often, you see, okay, land is being remediated, and then the first thing we think of doing is putting a park or a playground there, right? We take waste and we want to convert it into not office desks and chairs, but school desks and chairs, right? Now let's say, well, why do we put this into offices?
The most vulnerable of the receptors, place them there and make them play there.
Exactly.
Put a pond there so that they can swim in it.
Right.
Terrible.
Make them sit on it all day. And very often again, because the standards may not be there, we don't know what fumes are still being emitted and what toxins are still around. Fantastic. Can we open any questions from the audience? We've been all talking up here. Yes.
Hi, Mr.
Richa, maybe just introduce yourself for the camera.
Yeah, so my name is Dr. Richa Singh from Center for Science and Environment, and my question is for Mr. Mallick. So you mentioned in the very first slide, I think in the second slide, that a significant fraction of the legacy waste is inert in nature. So when we say inert, we actually are referring to a material which is biologically and chemically stable. So do you think it's correct to say that way? I mean, we should rather call it fine fraction, because it's most of the landfills that we are seeing in India are operational in nature. Like none of these landfills are unoperational or abandoned landfills. So it's difficult to believe that 60% or 70% of it is inert in nature, which cannot cause any harm to the environment.
No, I think, Dr. Singh, I think that is absolutely a very valid point, and that is why the inerts that I was referring to was within quotes. It is reportedly inert, because the moment you go into a detailed analysis of the trace organics, especially the persistent organics and trace metals in that so-called fine fraction, very inconvenient results come. Because of those results, it is difficult to dispose of that material, because that material suddenly, would under Schedule 2 of the hazardous waste rules start getting classified as hazardous waste. Especially the fine fraction, you are absolutely right. When you classify any material, you will get a classification of different sizes. So the heavy material lumps are actually inert. And especially if you wash them, then all the fine fractions are the ones that concentrate the heavy metals and the contaminants typically. There's no once again, no one size fits all, but typically the larger particles are truly inert. The finer you go, there's a concentration of contaminants. So those fine fractions are the ones you have to be very, very careful of. And unfortunately, those are the fine fractions that get classified as landfill material, low-lying areas. They go and they get dumped there. And they are the ones that actually and as an environmental student, they make me most uncomfortable.
Yeah, that's true, and I think that's the reason we should opt for biomining instead of going for like biocapping or any other solution, because here we are making sure that we are scientifically extracting the waste and then making sure that ease fraction is treated scientifically. I mean, what's your views on that?
I would request you to please study all the biomining projects and to understand whether that level of investigation alone on the trace organics and the trace metal level in the fine fraction has been done or not. If it is being done, fantastic. If it is being treated like it should be treated, if it is being stabilized as hazardous waste, great. If it is not, then we are actually creating a bigger problem than we are solving.
That's true.
My other question would be, if it is truly inert, then why are we transporting it hundreds of kilometers away? What is the environmental risk it represents?
Yeah, it needs a lot of policy interventions also. Like we need to have some standard operating. I'm so sorry. Maybe I'll restrict my question here also.
No, so good questions. I think things that need to be answered probably offline. But yes, sir.
Hi, good afternoon everyone. I'm Shyam Sundar from Tata Consulting Engineers. My question is to Indrabhushan Gokhale. Actually, the equipment that what you manufacture, so it's really fantastic, and I think whatever you supplied to Messrs. Yes2 Infra in one of the slides you mentioned, and I hope that is for the projects of Mulund dumping ground.
Yeah, correct.
Right. So actually, the Tata Consulting Engineers, we were the peer review for that project.
Right.
And actually, the thing is, what my question to you is, basically because of that equipment, whether the processing capacity of the plant, whether how much percentage it is increased with the normal trommels if you use that.
Right.
So that's my question.
Thanks for the appreciation. First of all, as I told during the presentation, is of course this means certainly in our whenever we come to some solution, it is always said keep it simple. It's like that. So whenever when we started this research, so there also we find that for example the trommel is used. So if you know about the Maharashtra, there is a earlier we have done the comparative study where the trommel is working and our machine is working. So it is like our machine is giving whatever the capacity is there. It is trommel is give for the same time. It is around 150 tons a day or something. Our machine can increase up to 10 times. But the cost of machine will be higher one. But if we see from the cost perspective here, we are telling that every step there is a, first of all we need to take care that our operating cost should be less, our initial investment should be less, and at the end of the day any contractor should earn more. So in that sense our equipments whatever even Mr. Mallick has told that one of the high equipment from our industry itself is used there. So such kind of technology if we used there, then really the process will be very fast for the separation, and certainly it will be, if we compare, it will be mostly around at least 6 to 7 times of the day. If it is 200 tons a day, we can 1000 to 1200 tons a day we can easily. And more than that, what happens is that if the moisture content go high, so we as a manufacturer we are ready to change on the some of the equipment, but of course we can't say that in a one day that we can replace trommel, because trommel is an integral part. But if we can utilize, if you can see in my one of my video, there also it can go inside the but trommel will be the stationary one. Even sir, we are coming with a trommel maybe next year with a track mounted trommels maybe by 2024, because we also see there is a lot of business, because 58 machine is a big number for us in 2 years. So in that case it can go inside that. So these machines can be utilized because our crusher is also a mobile crusher. It can go inside and utilize that in the with the trommel itself. And of course, we are working on the cost and whatever the customers you are using, most of things, even sir can know that about in Maharashtra or in Delhi, there are a lot of customer are very happy customer and they are getting good profit. Thanks.
Yes, yes. As per
Thank
the
you.
means customers' needs, you can customize the
Yeah. We have done a few points. Yeah.
Can we take one last question? I see one hand up here. There are no more hands up. Okay. Yes, sir.
Namaste, my name is Hanman Kaladgi, AW Environment, Belagavi Corporation. My question is to Bhopal Corporation representative and panelist also. He said case study about Bhopal, more than 11 lakhs tons he reclaimed and 21 acre and worth of 1.105 crores. Lastly, he said he is planning for construction of commercial establishment and residency. Is it viable? All case studies are for forest and other purpose. Even though we can construct a shed, storage shed also, but commercially he's telling.
Maybe we can get a quick answer. I'm not sure where there you are. Yeah. Can we get a...
Actually, what I told that we treated only 180 cubic meters of waste, legacy waste. Rest of the waste which was inactive was biocapped on that. And the land that was reclaimed has been, the proposal has been sent to the TNCP department. It's been processed with the principal secretary, sir. And when the land use gets changed, we will be using it in a commercial purpose, and also a bus terminal has been proposed there. There's no harm, but we will be getting the clearances from PCB. We will be getting environment clearances and the other committees like SIA and other things, because the land is in the most precious part. Like there is a nearby railway station, nearby overbridges there, and in front of the existing dump site there is a housing projects are very much in the lineup. So we'll be getting the clearances, and then the proposal for commercial project and ISBT will be implemented on the field.
Okay. So hopefully the clearances will be based on some of the aspects we have talked about today. Yeah. So let's do this. Let's have half a minute of closing comments by everyone. Sampath would love to hear from your 35 years looking at different aspects of waste. Maybe give you a minute to say what have you seen in this presentation? What do you think works? What do we need to be watchful about? And then maybe just half a minute for everyone to give your closing comments.
Hello. Yeah. From purely a Karnataka perspective, okay, out of these 343 towns which Bhanu was pointing out, I think, and out of the 196 towns which has got legacy waste, my own understanding would be that about 25 towns are big towns. Maybe the class 1 cities, maybe the TMCs, the bigger ones where maybe it's 50,000, 90,000, 1 lakh plus waste management. Rest of it are smaller ones. So I would sincerely request that no need to go through all these very sophisticated solutions which Mr. Mallick is pointing out and the team here is pointing out. Please get a simple total station survey done, get a volume estimate in place and go after your landfill process. Nothing more is required. Do the cleaning. Finally, the contractor we are going to get is not Zigma, is going to be some local contractor we are going to get, who is going to do this 3-part classification either with a sieve or with a Terex machine and go ahead and distribute the waste in a more safer fashion. Please ensure it is safe. Point number 1. When the complexity of the problem becomes larger, like if you are taking Mandur you want to handle or something like that, then I think all the expertise here has to come into place. So I think that thinking process differentiation has to be there. Otherwise, we will be lost in the kind of detailing which we are looking for. I was told that we are looking at some 200 DPRs to be prepared for Karnataka for the bioremediation. I would say get 200 waste assessments done so that you have the quantity properly done. And a proper base level identification. I think what Mr. Ravinder also pointed out, that we don't want to go below ground. What is your base? has to be very clearly told, because a lot of places in the past we have dug up the sites and then filled up the waste. Now we don't want to go back and create one more quarry out there and then come back and say, how do I now again fill up the quarry back? We don't want to get into that. So please come back to the base level, and I think that would be the way to go for us. For as the problem becomes more complex, like the Mangalore City Corporation Commissioner pointed out, complex problem, complex solution, care to be taken. Mysore, complex problem. Bangalore, complex problem. Please take complex answers. But for simple solutions, please take simple problems. Don't take some complex solutions. Especially in Karnataka, because in Karnataka, I think out of 343, almost 300 plus towns would have their own landfill, own waste management boundary. All this waste is lying within the waste management boundary of the towns. So that being the case, I think we should go for a simple solution. I think that's one input from my side. Thank you.
I guess.
One humble submission on the RDF disposal. Currently, apart from the cement plants, especially when the dump sites are not located in any of the 7 clusters identified across the country, then it's definitely a cost which is to be incurred with ULB. So, in this context, I would humbly request the government of Karnataka to advocate the idea of waste to energy. That's the only fallback as of now, because various other schools of thought are prevalent, but the waste to energy is still not gained the momentum as it requires. So the power purchase agreements with the private players, all those things can be relooked upon, and that's one submission which I have. Thank you.
Are there, sorry, just on that, are there other industries which could use the combustibles other than cement for their manufacturing?
What is permitted by the CPCB guideline is only the cement plants and the waste to energy plants.
Okay.
Yeah, I will again sum up like that. We should use it. We should use, and we're talking about the technology. We should use the simple technology. What sir told about that, and it as a as a manufacturer, we also believe. In fact, not only me, but there are the sweep manufacturer, other manufacturers, the screens. They are also ready to do the changes, and we generally feel that whatever the contractors means, what sir told, that is small contractors are taking lot of machine. It's very true, because whatever the machine they are putting, they are earning there. So that is our aim, that contractor should utilize our machine, and we also want to be the part of that that process, that the cleaning should be done for the city, and then we should have a healthy atmosphere. Thank you.
My main concern is, before finishing the biomining project, fresh waste processing must be started. Otherwise, it will be never-ending process. So that's most important.
Okay. Great. And just closing out, can I, Swati, can I ask you to go first with your closing comments? And just one thing, if you could add, is the Fukuoka method. Have there been any roadblocks you're facing in getting the pilot projects going? And is there something that the DMA in Karnataka could do to maybe become one of your first partners and clients?
Thank you. I think in terms of Fukuoka, of course, one of the biggest hurdle is also corporations coming together with their strong will to do this on the ground, because it can't be done by any private company or a multilateral agency on its own. So I think a collaborative approach, of course, is a need, and we would be really happy to hear from UDD or DMA if there's any need. As I said, it's a low-cost intervention, because we look into the affordability of resources and reutilization of material, along with training the capacity of the municipality and their internal strength, as well as local workers. So happy to collaborate with the state. In terms of closing remarks, I think I would just like to say that it's very much important to identify the problem first, have a proper baseline assessment in place, and then move towards solutions. So clearly, as an agency that has been propagating on evidence-based planning, we are happy to support DMA and UDD in conducting baseline assessments if they need it for their cities in Karnataka. We've done it for Mangaluru, we've done it for Mysuru, And we're happy to provide our technical inputs for any interventions in coming time and in the future. Thank you.
Great, thank you. And hopefully the landfill projects can then also get integrated into other circular economy, greenification of cities, and making cities more livable and sustainable through your other programs. Dr. Ravinder, your closing comments to the group.
Thank you, and appreciate all the experts coming in, and rather we would like to go for simple solutions. This Swachh Bharat Mission 2 has got a specific component of dumpsite remediation. It is about 9,000 crores. So comparing to the state contribution, the total cost should be around 27,000 crores to 30,000 crores. We would like to make the cities visibly garbage free at the first instance, and any challenges of any site specific problems, we welcome the experts and the development partners to come in and take it up, maybe in larger landfills. After remediation, we believe that land use conversion will be a challenge. Rather, it should be used for the city's own waste processing facilities, as many, particularly the larger cities, are facing the problem of new allotment of land for setting up facilities. At the same time, we are also thinking towards circularity, not to integrate the sanitary landfill into the integrated facility. Previously, our experience has been that plants attached to the landfill have not functioned to their potential. Rather, the landfills have been exhausted much before their estimated time. So, there is a circular economy issue also with the Ministry of Environment and CPCP. We would like to take the landfills separate. We believe cement plants are the best and not the waste to electricity. We are open to discussion, but cement plants are not uniformly spread across the country. Karnataka is lucky in that matter. So a lot of due diligence site-specific things need to be done. We agree that the RDF that comes out of the remediation may have more silt and dust and inert than the combustible matter. We need to find out a way of more shredding and maybe even washing it also to bring it to more combustible standards. Then only we can transport it to a longer distance. All of the points have been well covered, and we request experts to use their offices, good offices in their states and cities. We want to remediate the landfills as early as possible. Around 16 crore metric tons has been estimated. That translates that each person has deposited about 500 kg. That is about 25 years of legacy waste has been lying there. So if it is tackled immediately, a lot of changes in pre-qualification criteria are also required, as many experts have pointed out. We are typically looking at a project as a civil engineering project which will have a life of 50 or 30 or 50 years lifetime. It should not have any problem. That is not the way to look at it. Make it more broad-based so that the problem is tackled within the mission period. Thank you for giving me this time, and my thanks.
Thank you very much, sir. And hopefully the players here can respond to some of those things. And last but not least, Masood, any closing thoughts for us?
No, I think a lot that needed to be said has been said. I agree with a lot of the points that the previous speaker, Ravinder ji, just mentioned. I will just add one closing thought. The economic viability and cost efficiency, a number of these projects is associated with one factor alone. Assuming that the media, the matrix is not contaminated, assuming it is clean, then it must be given must-buy status. If that aggregate finds its way into PWD projects or embankment development by NHAI, the landfill rehabilitation project will be viable. Because we talk a lot about RDF. RDF is 15%, 20% in these mountains. 60%, 70% are the so-called inerts. If they are truly inerts, then it should get must-buy status or must-use status. And there's enough public works happening. There's enough road construction happening in India. And I think the cost efficiency of these projects will be dependent on that one policy intervention alone. Thank you.
Fantastic. Well, thank you very much. I'm sorry we did go over our time limit. I'll just close with two statements, two things I'd like to repeat. One is, as Dr. Ravinder said, landfill remediation should not be looked at as a civil engineering project. We need to look much deeper into the issues around it, and let's look for appropriate solutions based on the local conditions. But then invest enough time and energy and resources to understand the local conditions and what is needed there, instead of a one-size-fit-all or a one-cost-fit-all kind of approach. So with that, thank you very much. Please put your hands together for our panelists who have come to share their knowledge today, and thank you.